Hello everyone, we are from group D1CS1102C. In this video, we will be focusing on the techniques of differentiation, the meaning and core rules of differentiation, step-by-step practice problems, implicit differentiation and linear approximation. Greetings everyone, my name is M.AREFHAZEM and today we are going to explain to you about the techniques of differentiation. So in the question 1, we are asked to explain the meaning of differentiation and describe the following techniques of the product rule and the quotient rule. So, what is the meaning of differentiation? Differentiation is the process of finding the derivative or rate of change of a function. It tells us how a function changes as its input changes. In short, it's a way to calculate the rate of change or the slope of a curve at any specific point. According to the Leibniz 2008, differentiation is represented by the notation of dy over dx, which describes the ratio of an infinitesimally small change in dx, a variable y, to an infinitesimally small change in a variable x. This expresses the instantaneous rate of change of one quantity with respect to another. Next, I will explain to you about the techniques of differentiation based on the product rule and the quotient rule. What is the meaning of product rule? The product rule is a rule in calculus used to find the derivative of a function that is formed by multiplying two functions together. And what is the formula used in this rule? Well, the formula is 4'x equal to ux v prime x plus vx v prime x, or dy over dx equal to u v prime plus vu prime. I will explain to you about the quotient rule. The quotient rule is a rule in calculus used to find the derivative of a function that is formed by dividing one function by another. The formula used in this rule is 4'x equal to vx u prime x minus ux v prime x divided by open bracket vx plus bracket square, or dy over dx equal to vu prime minus uv prime divided by v square. Today we're looking at question 2a, where we need to find the derivative dy over dx for the function y equal to 5x cubed cosecant x minus 4. Because this function is made of two different parts multiplied together, we need to use the product rule. First, let's break our function down into two pieces, which is u and v. We'll set u equal to 5x to the power of 3, and using the power rule, its derivative is u prime equal to 15x squared. Next, we'll set v equal to cosecant x minus 4. Now, the standard derivative for cosecant is negative cosecant x cotangent x. By applying the chain rule, we also multiply by the derivative of the inside angle x minus 4, which is just 1. This gives us v prime equal to negative cosecant x minus 4 cotangent x minus 4 multiplied by 1. Next, we need to put all the variables inside the formula, which is we get 5x cubed negative cosecant x minus 4 cotangent x minus 4 plus cosecant x minus 4 multiplied by 15x squared. If we reorder the terms to put the positive algebraic term first, it cleans up nicely to 15x squared cosecant x minus 4 minus 5x cubed cosecant x minus 4 multiplied by cotangent x minus 4. Now, to get the final answer, we need to factor out 5x squared cosecant x minus 4, because both terms can be divided by 5 and both share at least x squared and both contain cosecant x minus 4. And when we factor out of the first term, we are left with just a 3. Furthermore, when we factor out of the second term, we are left with an x and cotangent x minus 4. Bringing it all together, our final answer is 5x squared multiplied by cosecant x minus 4 multiplied by 3 minus x cotangent x minus 4. This time, we are asked to find the derivative dy over dx for a fractional function of y equal to 2x to the power of 4 minus 3 divided by cos x. Because we have an algebraic function divided by a trigonometric function, our strategy here is to use a quotient rule. Firstly, let's identify our numerator as u and our denominator as v, and find their individual derivative. Our numerator here is u equal to 2x to the power of 4 minus 3, and using the power rule, the derivative u prime is simply becomes 8x to the power of 3. And for the denominator, we got v equal to cos x, and as we all know from our trig derivative rules, the derivative of cosine is negative sine, so v prime equal to negative sine x. For the second step, let's carefully substitute our terms into the formula vu prime minus uv prime divided by v squared, which is we get cos x multiplied by 8x to the power of 3 negative 2x to the power of 4 minus 3 multiplied by negative sine x divided by cos x squared. Thirdly, let's clean up the numerator. For the first part, we multiply cos x with 8x to the power of 3, which is we will get 8x to the power of 3 cos x. For the second part, we have a minus sign in front of the term and a negative sign attached to the sign x. When you multiply a negative by a negative, they cancel out and become a positive. So it it will become positive 2x to the power of 4 minus 3 sine x. And if we put it all together, we get our final answer, which is 8x to the power of 3 cos x plus 2x to the power of 4 minus 3 sine x divided by cos x square.
Okay, now today we will learn implicit differentiation. Today we will learn implicit differentiation. Question 3. Given in 2y plus y sin 2x equal to 2x power of 2 plus 3. Find dy over dx using implicit differentiation. What is implicit differentiation? Implicit differentiation is a method used when y mixed together with x in one equation. We differentiate both sides with respect to x. Whenever we differentiate a term containing y, we multiply by dy over dx. Step 1. Differentiate both sides. First, differentiate both sides of the equation. We need to differentiate each term. Remember, when differentiation y, we add dy over dx. So, d over dx in 2y equal to 1 over y divide dy over dx. Then d over dx y sin 2x equal to y of 2 cos 2x plus sin 2x divided by dy over dx. D over dx 2x power of 2 plus 3 equal to 4x. Okay, step 2. From the equation. After differentiation. First, 1 over y divide dy over dx plus 2y cos 2x plus sin 2x divide 2y dy over dx equal to 4x. We need to group all dy over dx term together. Then, step 3, factor dy over dx. Finally, factor and solve dy over dx. Dy over dx 1 over y plus sin 2x plus 2y cos 2x equal to 4x. Dy over dx 1 over y plus sin 2x equal to 4x minus 2y cos 2x. Right. Then, lastly, the final answer is dy over dx equal to 4x minus 2y cos 2x over 1 over y plus 2 plus sin 2x. This is a derivative using implicit differentiation. That's all from me. Thank you.
Now I will be answering question 4. This is how to use linear approximation to estimate the value of the fourth root of 60.02 minus 3 over 60.02. First, we need to know what a linear approximation is. It's a calculus method that uses the tangent line of a function to estimate a nearby value. Since 16.02 is very close to 16, we can use the number 16 instead to make it simpler. For our approximation point, first let me tell you the formula, which is fx equals to x over the power of 1 over 4 minus 3 over x. The linear approximation formula is linear x equals to fa plus f prime a of x minus a, where the a is equals to 16. Now let's replace the x with 16 to the formula. It becomes f16 equals to 16 the power of 1 over 1 over 4 minus 3 over 16. And if you use the calculator, you'll get 1.8125. Now let's find the derivative of the function. We replace again the x with 16, and you will get f prime 16 equals to 0.04296875. Now the difference between 60.02 and 16 is 0.02. So by using the linear approximation formula and replace all the number, you will get linear 60.02 equals to 1.8125 plus 0.04296875 times 0.02, and you will have your answer, which is 1.81335937. Now you've rounded 3 decimal places and you will get your answer 1.813. Therefore, the estimate of the value of root of 60.02 minus 3 over by 16.02 is 1.813. In conclusion, the linear approximation allows us to estimate function value using a nearby point and the slope of the tangent line. This method of calculation is easier while still provide a good approximation.